So what we're going to do, once we've drawn a cumulative frequency graph, we could be asked to find values from that graph. So for example here, I'm going to find the median, the lower quartile, and the upper quartile from my cumulative frequency, because unlike before where we had individual values that we could find the middle value, well, we can't do that because now everything is grouped together in a table. So we can't simply just find what our middle value is because we only have frequencies. So we do have a total number that we've sampled. So for example, here it's 30 different plants that we sampled. And now we can use that value and we can read off our graph to find our median and quartiles. So for the median, what we're going to do is we're going to take our total value and we're going to divide it in half, so divide it by 2, to find the middle value frequency. So here I'm going to say 30 divided by 2, so my value is 15 plants. So then I'm going to take my graph that I've just drawn, and on the cumulative frequency axis, I find my halfway value. So in this case, it was 15. So now at 15, I go and I draw a ruler line along until I reach my graph. Once I reach my graph, then I can read down and draw a line down to my x-axis to find my specific value. So here I have got 12 centimeters, which is then the median. So the median here is going to equal 12 centimeters read off of the graph. Then the lower quartile, we do the same thing. So we take the total, but now I want, instead of half, because the lower quartile, remember, it's the half of the lower numbers. So I'm going to take that total and I want a quarter of it. So what I can do is I can times it by a quarter to get my value. So if I look on my calculator, I take my total of 30 and I times it by a quarter and I will get 7.5. So that is what I'm looking for on the cumulative frequency axis. And then for the upper quartile, I'm going to do the same thing, but I want the quarter from the top half. So I can take the total and I can times it by 3/4 because I want the one at the top. So if I do that and I say 3/4, I'm going to get a value of 22.5. So those are the cumulative frequency values that I'm looking for on the graph. So I've already found the median. Okay, so this one is for the median. Then my lower quartile, I'm looking for 7.5. So on the graph, on the axis for cumulative frequency, I am going to find 7.5 and I draw a line across till I reach my graph, and then from the graph down to the x-axis, and I find that my lower quartile is then 10. So that's going to be 10 centimeters. And that is then my Q1. And then my upper quartile was 22.5. So at 22.5 on my y-axis, I draw my line across till I reach my graph. And then from there, I go down to the x-axis and I find that I've got 14.5 as my Q3. So that's going to be 14.5 centimeters. And now I have a lower quartile and an upper quartile. I can find the interquartile range because I can say the interquartile range is going to be the upper minus the lower. So 14.5 minus 10 is going to give me 4.5 if that's needed. So we're always going to read off our graph. So you take your total and you halve it to find the median. From that, you halve it to find the lower quartile, and then from the upper, you halve it to find the upper quartile. So if I look at a different kind of example now, sometimes I'm not just asked to do medians and quartiles. Sometimes I can be asked for something like this. So here, they've given me values and they've asked me to construct a cumulative frequency graph. Now, because these weren't continuous, because I see dashes instead of greater than or less than signs, I made them continuous first by subtracting 0.5 from the first one and adding 0.5 to the second one. And then I drew my graph. And now it says, components that weigh less than 64.5 grams or more than 87.5 grams were rejected. Use your graph to estimate the percentage of components that were accepted. So now I'm going to take that graph, and the first thing I'm going to do, from my x-axis, because I'm dealing with weights that they were given, I'm going to find 64.5 on there, and I'm going to draw a line up to find my number of parts that were less than that on the cumulative frequency graph. So I'm going to say 64.5 is going to be here, and I'm going to draw up, and from there we draw a straight line across, and we find a value of approximately 15 on there. And then I find 87.5, and I draw up from my x-axis to my graph, and then where it hits my graph, I go along to the y-axis, and we find that it's approximately 485. So 15 is the value that is less than that number. Okay, so what they asked for, they said the components that weigh less than that or more than the other one were rejected. So less than that is 15. So that's going to be rejected. More than is going to be this little part up here, because this value is everything less. It's everything on this side of the graph. So I want more than, which is just the little top part. So in order to find that, I would say my total minus the value that I found. So the 500 minus that 485, and that will give me just that part up there. But my question says that I want to find off the graph the components that were accepted, which was anything that was less than 87.5 and more than 64.8, which means everything that's in this area here. So all I need to do is I take where I found my 87.5 grams of my 485 minus the ones that were rejected that were less than, which was the 15. So I'm going to say that minus 15 to get an answer. And then it says that I want to estimate the percentage of those. So in order to find percentage, because now this is number that were accepted, I'm going to say that divided by my total, which was 500 times 100 over 1. So my percentage works out at 94%. So if I look at something different with another example, here I've been given the cumulative frequency curve, and that is of the amount of time spent by 50 people in a supermarket on a particular day. We need to use the graph to estimate how many people spent at least 17 minutes, but less than 27 minutes in the supermarket. So at least 17 minutes. So on here, on time, we go and we find 17. We draw a line up and across to the X and Y axes. And we find that that's 9 people. So at least means that we want everything more than that of those 9 people, but less than 27. So now I find 27 on my graph, draw my line up and across, and I find that it's 31. So now, because I want more than the 17 but less than the 27, I want everything here in there. So what I'm going to do is I'm going to take my top value of 31 minus my bottom value of 9, and I find that that is 22 people, because the cumulative frequency is the people. So that's the difference in there. That's shopped for longer than 17 but less than 27 minutes. Then the next question says the value of T where 60% of the people spent less than T minutes in the supermarket. So the first thing I need to do is find 60% of the people. So there is 50 people in total. So I'm going to say 50 times by the 60 over 100, because that's my percentage. So 60% is 60 over 100. And when you say 50 times 60 divided by 100, you end up with an answer of 30 people. So now that I know that the 60% is 30 people, that says that it's where they spent less than that amount of minutes. So I am going to find 30 people on the graph, draw a line across and down. And when I do that, I find that I'm dealing with 26.5 minutes approximately. And now I can leave that answer as it is because this represents everybody here on this side of the graph, which is less than the amount of minutes. So that answer is then going to be 26.5 minutes for less than. But now the next part says, find the value of S where 60% of the people spent at least S minutes in the supermarket. So at least means that was the minimum amount of time and they spent more than that there. So if I want the value for at least, this was the 60% that were less than. So now I need the top 60% instead, because this represents more than on this side, because it's higher, because they spent at least that amount of time, meaning they spent that amount of time and more. So in order to do that, now getting the top 60%, I need to take my total of 50 people, and from the 50 people, I'm going to minus that 60% that I had before. So I'm going to say 50 minus 30, because that was the 60%, equals 20 people. So now if I find 20 people, this means it's the top 60%. This was the bottom 60%. Now I'm going to find the top 60%. So at 20, I'm going to go across until I find my value and then down. And I find that my answer is 23 minutes. And now that's everybody on this side of the graph. So this is the top 60%. Before, remember, on this side where I found this, that part is the bottom 60%. So my answer is going to be 23 minutes. Then to find the median, I do what I did before. I have a total of 50, so I want to divide that by 2 to get the half. So half of 50 is going to be 25. So at 25, I draw my line across till I get to my graph, and then down on my axis till I get to X, and I find that the median is 25 minutes. Because when I draw a line down, I get that. The interquartile range, meaning I need Q1 and Q3, and then I'm going to say Q3 minus Q1. So now I need to find the value that I'm looking for. So if I find my Q3, I'm going to say 50 times 3 over 4 to give me an answer of 37.5. So then I find 37.5 on my graph. I draw a line across to my graph and then down to my x-axis, and I find that my value is 29. And then my Q1, I'm going to say 50 times a quarter. So I'm looking for my value of 12.5. So at 12.5, I go up, draw a line across from my y-axis down to my x-axis, and I find my value of 20. So I say 29 minus 20 equals 9 minutes. So those are the kinds of questions you can get from a cumulative frequency graph. But as long as we know what we're looking for, if it's percentage or if it's median and quartiles, we always just read off our axes, either off our x or our y, depending on what we're looking for.